In the statistical process, after data is collected, it then needs to be organized and presented in a manner that makes it easy to understand and analyze. A basic method of organizing data is to construct a frequency table. At the end of this lesson, students should be able to understand the terms discrete and continuous variables, grouped and ungrouped data, frequency, as well as construct a frequency table for a given set of data, whether that data is ungrouped or grouped. Data is the most important concept in statistics, but it is often confused with the word information. So what is the difference? Well, data refers to unorganized facts, for example, the number of books in a student bag. Now that might total 9, and therefore the number of books in that bag, that's just a fact, straight data, but it hasn't been organized yet. Information, on the other hand, refers to organized facts, for example, values put into a table. And as we look on the right side of the screen here, we are seeing a frequency table where values are being used to populate the columns of this frequency table. This would constitute what we call information. Another very important concept in statistics is that of the variable. Now, a variable is an attribute that describes a person, place, thing, or idea. For example, hair color or shoe size. The values of a variable can vary, meaning have different values, and that is actually how it gets its name, variable, meaning it's able to vary. As an example illustration, we could think of hair color as having two different possible values, one being black and the other being silver. So black and silver are two possible values of the variable hair color. Another example of illustration of this is if we are talking about shoe size. There can be two possible values, one being shoe size 8 and shoe size 10. 8 and 10 are two different values of the variable shoe size. Now, there are discrete variables and there are continuous variables. A discrete variable is one that is a countable attribute, meaning it can be counted. You have to count it in order to obtain the value. An example of this is the number of cars in a car park of a school. And if you look to the picture on your right, here's a car park with cars parked in it. You can take up the challenge to determine just how many cars are parked there. When I did it, it came up, I could only see about 14 to 15 cars, but maybe you could see some more. So try it out if you like. Pause the video and count the number of cars in that picture. Now, discrete variables are generally whole numbers, and that makes sense because you're counting, you would normally count in the following manner: 1, 2, 3, 4. Nobody really counts and says 1.5, 2, 3.5. Nobody really counts like that, right? So expect discrete variables to take up whole number values. For continuous variables, which are actually measurable attributes, for example, height or weight, these tend to take up any decimal value within a specified range. So for example, if the range is from 5.0 to say 5.5, you might get values like 5.0, 5.1, 5.15, or 5.20, etc. That is expected if your variable is continuous. So we have discussed data, we have discussed variables and different types, discrete and continuous. But now we want to talk about how to actually organize the data. There are two ways in which we can organize data before we construct a frequency table. One is grouped and the other is ungrouped. And we're going to look at ungrouped data first. Now, ungrouped data refers to data organized into single values of an attribute. The attribute in this example picture that appears on your screen now is height. Height is the attribute. And 139, 145, all the way to 138, these are all single values of that attribute height. And on the right column, you have these values 1, 2, 2, 1, and so on. These are the frequency in which the height, that particular height, occurs in the data set. So how you would read this table is you would say, for example, the height 139, there is one such data item with that value, one data item that has a height of 39. There are two data items that have a height of 145, and there are two data items that have a height of 150. So this here is an example of a frequency table for ungrouped data. For group data, what we do is we take the data and organize it into several fixed classes or groups of values. So with this table that appears on your right, observe the difference with the ungrouped data table and this one. What you would observe, or what you should see, is the different classes. For example, 11 to 15, 16 to 20, 21 to 25, and so on. Right? These represents different ranges of values. Okay, and normally we would group data if the data is continuous. Okay, so bear that in mind. Or we would normally group data if it's a large set and you want to kind of compact your table so that you capture all the values, even though it's a very large data set. So this here is a frequency table for group data, and the main difference is the data itself, the data values, they are organized into fixed classes or groups. Each class has the same size or width. Okay, so it's time to pay homage to the actual title of the lesson and construct a frequency table. So first we're going to construct one for ungrouped data. So with the example on screen reads, a class of 30 students counted the number of books in their bags on a certain day. The number of books in each bag is shown below. So here we have just a scattering of numbers, no structure really applied to it. It's just raw data, raw facts, unorganized, and so it's our job to put some kind of structure to this data, and so we're going to construct a frequency table to do just that. Note well that ungrouped data organization is suitable for relatively small data sets. This is just 30 students, so it should not be a problem to organize the data into single values. The first step, therefore, is to organize the data into individual values, right? And so what you would have is the first column of the frequency table would be labeled according to the attribute. The attribute in this case is the number of books in the bag. So when we scan through these numbers, we will get the different possible values that the attribute could take, being 1 to 7. So we have 1, 2, 3, 4, 5, 6, 7. So this is stage 1 complete of constructing the frequency table. The second step would be to construct a tally. Now this is not always a necessary step, but it is highly recommended to avoid making mistakes. What you do is you take the value of the attribute and you count how many times it appears in the data set. So for example, we're actually going to do all of the values of the attribute. So for 1, we just need to look in the data set and see how many times 1 appeared, and you will get 2. So 2 strokes. How many times did 2 appear? You will get 3. And for the other values, I'm just gonna put them in. You could always pause the video and verify whether or not they are accurate, but you know, I'm hoping you could trust me, they are accurate, but just for the exercise sake, you could just pause the video and do it yourself. So third step is to add and populate a frequency column. We already have the data attributes organized into single values from 1 to 7. We have the tally, how many times each data value appears. And so now the frequency column is you're just going to look at the tally column and, well, turn those strokes into actual numbers. So we see 2 strokes here. So for the frequency column, we just write the number 2. Next, we see 3 strokes. And so we're going to just write 3. And so you're just basically interpreting the tally count and put the number attached to it. So 5, 6, 7, 4, and 3. Complete the frequency column, and there you have it. This is a frequency table for ungrouped data. So it's really just that simple. 3 steps. 1, organize the data into single individual values. Then you construct a tally, which is not a necessary step. If you are confident enough to just count and populate the frequency column in 1 step, then that's very possible. You can do that. But the tally is just to be on the side of caution and avoid any mistakes. And the 3rd step would be to add and populate this frequency column. So that here it is, students, frequency table for ungrouped data. Next, we're going to illustrate how to construct a frequency table for grouped data. Now, group data organization is best when we have an attribute that can take up a large number of different values. For example, scores on a test out of 100, because you might have, well, also depending on the number of students, you might have many different values from 0 to 100. So, suitable organization would be to take those possible values and group them into fixed classes. So that would be your first step when constructing such a frequency table. You would want to organize classes of fixed widths for the data. So what that would look like is, for example, what we have here. We have the score in the exam is the actual attribute, and you could score in the range 0 to 10, 11 to 20, 21 to 30, all the way up to 91 to 100. Each of these classes are the same width, okay? And that would be your first step in constructing a frequency table for group data. Next, you would construct a tally, and again, this is not always a necessary step, but it is highly recommended to avoid mistakes. So what we have here is in the range from 0 to 10, no one scored that amount, so your tally will be 0. In the range 11 to 20, one person scored that, so you have 1 stroke. 2 strokes for the group 21 to 30, none for 31 to 40, and completing this tally column, you have these different strokes and bundles. All right. So after you've done the tally column, then you would add and populate a frequency column, which would just be very easy since you've done the hard work counting up the different values in the tally column. So for example, here in the range 0 to 10, no one scored that, so you just convert the absence of a tally into a number of 0. 1 stroke is 1, 2 strokes would be 2, and let me just jump down here to the group 51 to 60. You have 1 bundle of 5 plus 2 strokes, and that equates to 7. So you write the actual number 7 in the frequency column. Okay, and so once done correctly, these would be the values that populate the frequency column, and that's all there is to constructing a frequency table for group data. So your first step, organize the data into fixed classes. Second step, not necessary, but do a tally of the different values within that data range, and then you convert into actual numbers and populate the frequency column. So that is how you would construct a frequency table for grouped data. So in summary, first we need to recall that discrete variables are countable attributes and are generally whole numbers, whereas continuous variables are measurable attributes and can have decimal number values such as 5.22 or 6.3. Just a note, continuous variables, you usually would have to use some sort of measuring instrument like a measuring tape or a scale or something of this sort to actually measure the value. Group data, this is just one way to organize the data that you've collected, and that means organizing them into classes of fixed widths, for example 11 to 15, 16 to 20, and so on. Whereas ungrouped data, that's data organized into individual values 22, 23, 24, etc. Frequency, well, that just refers to the number of times an item or attribute occurs in a set of data. Now, when it comes to actually constructing a frequency table for ungrouped data, first you want to organize the data into individual values, then construct a tally, although this is not always necessary, and third, you want to add and populate a frequency column. Constructing a frequency table for group data is very similar. However, the difference is in the first step. In the first step, you will organize the data into several classes of fixed widths. The next two steps are pretty much carbon copy of the process. When you're constructing a frequency table for ungrouped data, you would construct a tally and then add and populate a frequency column. So the critical question at this point is, why do we do all of this? Why go through all this hard work of getting data, organizing it into some kind of table? Mind you, a frequency table is just one of the many ways you can organize or structure data. But why are we doing all of this? Is it just to pass time? If you like, you could pause the video and just think about it for a while. Why? The question is, why are we doing all of this work? Okay, if you've paused the video and actually thought about this and you have an answer, I am going to trust that you do have the right answer. But here is my answer. Okay, the reason why we're doing all of this is to prepare the data for subsequent analysis. Okay, and this is very important to understand for fifth form students who are doing their school-based assessment. Usually the mathematics school-based assessment comes under two categories. Well, usually, right? There's possibly a lot more. From my experience, I've seen they either come under the category of mathematical modeling or statistical investigation. Mathematical modeling is when you would take a scenario, real-life scenario, and basically convert it into mathematical language and analyze it and come up with some kind of solution for a problem that exists within that scenario. The second category is statistical investigation, and that, of course, involves the statistical process, which is as follows. One, you would gather the data. Two, you would organize and structure that data. So that would involve, as this lesson treated, with the construction of perhaps frequency tables, but there's also the possibility of constructing pie charts, bar charts, and basically any statistical diagram that will make the data more readable and easy to understand. Now, after you've done all of that, it's time to analyze the data, and that basically involves a lot of number crunching. You're going to apply mathematical formulae to basically extract the hidden truths within the data, the hidden information in the data, after which you would discuss whatever findings emerged, come up with some kind of reasoning behind it. And that's pretty much what a statistical investigation, school-based assessment for mathematics may look like. So just to recap, for the SBA, it would be gather the data, structure the data, analyze the data, and then discuss whatever findings the data you were able to extract from the data. All right, so this is why we construct frequency tables. We want to prepare the data for subsequent analysis. We humans don't, when things are unorganized and just sort of scattered about the place, the chaos is kind of hard to make sense of. So structuring the data, organizing the data makes life easier so that we can now go deeper and study what exactly is the data saying to us. Okay, so that is the reason why we do all of this. For part 3 of our statistics series, we're going to be looking at the class features for group data distributions.